Hey guys, it's Mr. Gilsdorf. This is Unit 1, Section 3. This video is for General Chemistry, so if you're in honors, please close out, switch to the other video. Otherwise, let's go. So we've already seen the general idea of the quantum mechanical model for the atom, so we know that there are energy levels. As you move out, the energy levels become more energetic or a higher energy level, and the electrons really need to stay organized in these levels in order to not collide with one another and to function properly. If an electron is in the outermost energy level of whatever atom that is, then they are called the valence electrons. We already saw that they are located at set distances from the center of the atom, designated as N1, N2, N3, etc. And they can contain a specific number of electrons. The closer you are to the nucleus, the less electrons you can hold, because you have fewer sublevels. We'll talk about sublevels in the future, don't freak out. And fewer ultimate electrons. As you move higher in the energy levels, they can hold more and more electrons as they go up. Many of you may remember some of these from middle school because many of you had to memorize some of this stuff in middle school for some reason. But either way, we'll be working with it in the future. So this is one of the biggest key concepts here, the idea of ground versus excited state. When an electron is at its normal energy level, the normal state that we know that it usually is at, it is referred to as its ground state. So let's just say, for instance, we had an electron that had 100 units of energy and it was at energy level 1, or n equals 1, okay? And let's say that it gets struck with energy, electricity or light, and let's say it's 100 units, okay? The electron had 100 units, now it has 200 units. So what we would then see is that newly energized electron would move up to the next energy level, okay? Now, it can't necessarily stay there. That energy level likely already has electrons in it. Plus, that electron isn't traditionally supposed to be in that particular place, and something needs to occupy the first energy level. So it's going to drop back down, okay? And when it drops back down, that energy that it added to go up to 200 in this particular case is given off, okay? So that's pretty much what it's all in these pictures. The electron, when it's at its traditional state, is referred to as its ground state. Once it absorbs energy and jumps up, we call that its excited state. It can't stay at the excited state, so it has to fall back down, and the energy it absorbed, it releases. That energy released is what we're going to be doing a lab with, and that gives off different colors and different radiation from the atom as it goes through that process. You're going to hear me say the word photon a lot. Photon is really just a vocabulary term referring to a packet of light energy, a unit of energy. And this was just kind of cute. Primarily just because the sun looks cute. It's not even that funny. He's just adorable. So I am certain that many of you have seen the electromagnetic spectrum at this point. So you know that it consists of all the light energy that we know of. The primary ones being radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma, okay? And in the order I just read them, that is in order of increasing energy, meaning in order of decreasing wavelength. So when we're looking at the waves, make sure you keep an eye on this particular column here that I just circled. The lower energy waves have really long wavelengths, so the waves are really spread out. Shorter energy waves are a lot more close together. Higher energy waves have a shorter wavelength, which means they're a lot more close together, okay? So the highest energy waves are gamma radiation, the lowest would be, radio and microwaves. So if an electron falls from a really high energy level, let's say n equals 7, down to n equals 1, it's going to give off a high energy wave. It's going to give off either visible light up through ultraviolet, X-rays, or gamma rays. If it is falling just from N2 to N1, then it's probably going to give off one of the lower energy waves. In case any of that vocabulary was scaring you, wavelength is basically just the distance between the same point on two different waves. So if we say crest to crest or trough to trough, it's essentially just saying how far apart the waves are. Frequency is basically how many waves are passing a certain point at a certain time. So essentially how fast it is. Higher energy waves have a higher frequency because they are closer together, so more of them are passing a certain point at a certain time, whereas low energy waves are going to have a lower frequency because they are more spread out with longer wavelengths. There's not a whole lot to say about visible light other than that those are the light that we see and our entire world is based off of it, so I guess that's a lot to say. But The wavelength system that we were just talking about, longer wavelengths at lower energy, shorter wavelengths at higher energy, holds true for visible light as well. So the longer wavelengths are found at the lower energy end of visible light. The shorter wavelengths are found at the higher energy end of visible light. So make sure that you're studying the extremes. Know that radio waves are the longest wavelengths of the electromagnetic spectrum. Gamma radiation is the shortest, and then within visible light, red is the longest and purple is the shortest, or violet, excuse me. Every single color that we are capable of seeing is a specific wavelength of light. So when you're looking at something, your eyes are registering exactly the wavelength, calculated precisely. It transfers that information to your brain then perceives it in a certain way. So really it's just converting. You're just converting wavelength into color in your brain. So, those of you that are like, I'm not good at conversions, well, you do it all the time with light, unless you're colorblind, and I'm sorry. But you still do it, you just don't do it correctly or in the same way that everyone else does, and that's okay, all right? Because people can be unique, and that's cool. When electrons emit energy, they emit it when they're falling back down to their ground state, because remember, if I take that energy in and jump and I go back down, I got to get rid of that energy before I go back to my original state. The color they emit corresponds with the wavelength of light that they are releasing, or the wavelength of energy they're releasing. Higher energy waves are going to give off shorter wavelength, higher frequency light and energy. So here's a great example. If we have an electron that started at N2, jumped up to N3, and is now falling back down, that's a pretty short fall, so it gives off a low energy, or a lower energy, longer wavelength light like red. Something falling from n equals 4, maybe it came from n equals 2, and now it's falling back down and it's giving off that energy. It's a further fall, a bigger fall, so a bigger difference in energy, so we're going to see a higher energy wavelength given off, in this particular case green or blue or purple or something like that. The coolest thing about all this is that every single atom will give off a specific set of wavelengths. So if you've ever wondered, okay, nobody's ever been to Neptune, how do we know it's made of methane and nitrogen and other things like that? This is how, okay? We look at the light that they emit, or the elements are emitting when they're reflecting off the sun's light, and that's how we can figure out what they're made of. They're going to give off specific wavelengths. So we know that it is made of carbon and hydrogen-based compounds because we know that that's the light that they give off. So that works in our solar system, it works beyond our solar system, it works everywhere. So that's the greatest thing about this particular section, is understanding the idea of atomic spectrum, and I will show you guys some stuff with that next time. Please summarize your notes, do your practice problems, and I will see you next class.